Alright, so you should be done with your test, your volume test, doing all the corrections on it. Now we're going to go over the exponent rules again. Y'all don't quite get this yet. So I'm thinking that I can explain it a different way, and maybe I can get some more people on board this time. And we're going to retake the volume if you need it, or we're going to retake this if you need it tomorrow. Maybe the next day for this. Alright, so for this problem, this is the product rule. They call it the product rule because we are multiplying. Here's the multiplication. So we have a shortcut way, but nobody can remember it. So let's do it the long way. So 3 to the third power is 3 threes. And 3 to the second power is 2 threes. So all together, that is 5 threes. And that's all there is to this. Now technically the product rule says to add the exponents. You get the same answer if you do that. If you add 3 plus 2, you still get 5 and the base stays the same. If you can't remember the rule though, this is a perfectly acceptable way to do this problem. Alright, let's try this. So we have 3 4 times, and we have 3 twice. So all together we have 3 6 times. So that one wasn't really a whole lot different than number 1, but no matter what these numbers are, no matter what those numbers are, we're still going to do the same thing. We're still going to write this, however many times it says. We're going to write this, however many times it says. And if they're all the same, we can write an exponent to show how many there are total. Let's try a different problem. Let's try power rule. Alright, so this one is power rule. You know it's power rule because it has a power on the outside. That's another word for exponent. So we know that this exponent tells us how many times to write the inside. So we're going to write 3 to the 4th 3 times. And looking back at number 1 and number 2, this is 4 threes. So we can write that. So is this. And so is that. So all together, we have 12 threes. The shortcut rule for power rule is to take the exponents and multiply them together. 4 times 3 gives us our 12 that we got for our answer, without us having to do all this extra work. But if you can't remember the rule, but you can remember to do this, you're still going to get the same correct answer. So don't worry about remembering the rule. Worry about understanding what the exponents actually do so you can get this, so you can get that, so you can get your answer. Alright, here comes another one. Try this one. On this one, we have 2 to the 4th 3 times. Which means we have 4 2s. 4 2s. And 4 2s. So altogether we have 2 to the 12th. So on these problems, you're just going to remember how to do the exponents. What these exponents do. This makes this happen 3 times. If you can remember the rule, you might as well use it because that is way faster than writing all of this. Alright, here is quotient rules. So for quotient rule, we're going to write on the top 4 3s. And on the bottom, we have 3 3s. According to the rules of math, if I can do it to the top, I can do it to the bottom. So I'm going to divide the top and the bottom by 3. That gets rid of both of those. And we can do it again, and we can do it again. Because each term has a 3. We can break the 3 out 3 times. So what we're going to end up with is this one lonely 3 sitting on top of the fraction, and that is the answer. Try this. On this one, we have 2 2's on top and 3 2's on the bottom. We can get rid of 2 of the sets of 2's, and we still have this 2 on the bottom. We can't leave it like that. It has to have something on top. So we're going to put a 1 on top. And we're always going to use 1 if there's nothing there. All right, here is another product rule. This time, it gives us a product rule with letters. But it doesn't really make a big difference. So we have our 4 and our 1, and we're going to multiply those together, and that equals 4. And now we're going to write in twice and in once. So we know we're going to have 4 in to the 3rd power. For the shortcut, you multiply those, that equals 4, and then you add these, and you get 3. Either way, you get the same answer. Do whatever is more comfortable for you. Try this one. All right, on this one, we have 4 and 1 and 2. If we multiply those, we get 8. We also have 2 m's and another m and another m, and that gives us 8m to the 4th. For the shortcut, you can do 4 times 1 times 2 is 8, and 2 plus 1 is 4. All right, here is a power rule with a letter in it. We're going to treat each of these as individual pieces. So this 2 is going to get a 3 on it. And this n is going to get a 3 on it. 2, 3 times. N, 3 times. So we're going to end up with 2 times 2 times 2 is 8. N, that's 3 n's. So 8n to the 3rd is our answer. For the shortcut, 2 to the 3rd power is 8. 1 times 3 is 3. Try that one. All right, so long way, 3, 4 times. X 4 times. So I get 3 times 3 times 3 times 3, which is 81, and 4 x's. So that's my answer. Shortcut. 3 to the 4th power is 81. 1 times 4 is 4. On this one, We have a 4 on top with 3 ends. We have a 5 on the bottom with 5 ends. We can cancel out 3 of those ends. This fraction does not reduce, so it's going to stay the same. And where are the ends? The ends are on the bottom. And there's 2 of them. Try this one. Alright, so on top we have 5 V's. On the bottom we have 2 V's. Cancel out 2 of them. This fraction does reduce this time. It reduces by 2. Because 2 goes in 2 and 2 goes in 6. So 2 goes in 2 1 time. 2 goes in 6 3 times. We have 3 V's on top. So that's our answer. We could make it a little bit simpler if we wanted to take that 1 off, because we really don't need 1's in front of variables. So we could have v to the 3rd over 3. And that would be a good answer too. I actually like this one a little bit better. Alright, now we're going to include negatives. So negatives change the location in a fraction. So if the negative is on top, we move it to the bottom. If it's on the bottom, we move it to the top. So right now, everything right here is on top of a fraction. The 4 does not have a negative on it, so it's going to stay where it is. The m has a negative on it, so we're going to put it on the bottom, and the 2 becomes positive. This one has a negative, so we're going to put it on the bottom, and the 3 becomes positive. So we have 4 on top, and how many m's altogether is this? That's 2 and 3. All together makes 5. And that's our answer. Try this. Alright, for this one, the 4 and the v and the 4 are all positives. This v to the negative 2 gets moved to the bottom and it becomes positive. So 4 times 4 is 16 with a v on top, and we have 2 v's on the bottom. We're going to cancel out those v's, and we're going to end up with 16 over v, and that is our answer. Let's try this one. The whole thing has a negative on it. So the whole thing is going to move to the bottom. We're going to put a 1 on top so it's not blank up there. Alright, so we're going to write 3 into the 4th once. And there's nothing else we can do to that problem. So that's our answer. This one is going to have a similar issue. It has a negative on it, so we're going to move it to the bottom. The whole thing. And it has a positive 1 now. And a 1 on top. When we write this once, we're going to end up with 2k to the negative 3. And that k to the negative 3 is in the wrong place. So we're going to move it to the top, and it's going to become positive. And there's nothing else we can do to this problem. This one, we have a negative on the bottom. It needs to move to the top. This 2 does not have a negative, so it stays on the bottom. So we have n to the 4th on top and 2 on the bottom. Alright, if you have any questions, make sure you ask me in class. Thanks.